Hi everyone, I am Neelav Bhatiya and I attempted my JEE in the year of 2020 where I secured an All India rank of 1755. So in the previous session, we started with the chapter Permutations and Combinations. This is chapter number 6 in the NCERT book, and we were able to solve exercise 1, 2 and 3. And today in this session, we'll be able to finish this chapter by discussing exercise 6.4 and 6.5. Right. So without wasting any more time, we can just directly jump to our exercises and just start with them. So exercise 6.4. In exercise 6.4, the first question that we have to solve is that NC8 equal to NC2. This is given to us and the value of N has been asked from us. Correct. So we know that whenever we are taking combination and when we are using the formula of NCR, some basic equalities hold true. For example, if NCR equal to NCP, then this can only be the case during two conditions. Either when R is equal to P or when R plus P is equal to N. Correct. So as we can see, in this case, R and P are not equal because R is given to us as 8 and P is given to us as 2. So the only other condition that can be true is R plus P equal to 8. When we apply this condition in our above question, we get N is equal to R plus P, and let's plug in the value of R and P from the statement that has been given to us in the question. R will be 8 and P will be 2. So the value of N is equal to 8 plus 2, which is equal to 10. So this was a very straightforward question asked upon the property of NCR. And if you had gone through the theory that has been given to you in NCERT, this was a fairly straightforward question for you to solve. So remembering the theory is sometimes enough to crack the question. And that is a key takeaway from this question, that you need to be thorough with your preparation regarding each and every formula. And that should be at your fingertips. And that is how you're going to be able to solve these questions in a jiff. Right. And after that, we have been asked to find the value of NC2. So how we have first figured out the value of N equal to 10, and now we need to calculate the value of NC2. So let us plug in the value of N in the equation NC2 and calculate the value of it, right. So N has been solved by us, and the value of N is 10. So NC2 is nothing but 10C2, and 10C2 could be written as 10 factorial upon 10 minus 2 factorial into 2 factorial. This is nothing but the expansion of NCR, where NCR is equal to n factorial upon n minus r factorial into r factorial. Correct. So this is 8 factorial, and up above we have 10 factorial. This can be cancelled out, and we can write 10 into 9 in place of this, right? Because 10 factorial could be expressed as 10 into 9 into 8 factorial, and that's how we are able to cancel out 8 factorial from the numerator and denominator. Correct. So after doing that, what we are left with is 10 into 9 divided by 2 factorial, which is nothing but 2 itself. So 10 into 9 upon 2, cancel out 2 here, and the final value that you are left with is 45. Correct. And that is the answer of our question. So that was question number 1 for you all. Now let's move on to question number. In question number 2, we have been asked to solve 2NC3 upon NC3 equal to 12 upon 1 and 2NC3 upon NC3 equal to 11 upon 1. So what I've done here is I've simplified the ratio in terms of fractions. So if you can see, 2NC3 upon ratio NC3 equal to 12 ratio 1. This is the first part. And the second part, this is equal to 11 ratio 1. This is the second part, right? So before solving this question, what I'm going to do is I'm going to simplify the LHS into something that is more manageable. After I have done that, I'll plug in the value of these two ratios and I'll solve n for the first part and for the second part. That is going to help me just simplify the equation of 2nc3 upon nc3 just one time, and I'll be able to then use the fraction to calculate the value of n for each of the given cases. Correct. So let us first simplify 2nc3 upon nc3. This is the LHS of this question. So 2nc3 divided by nc3 could be written as 2n whole factorial upon 2n minus 3 factorial into 3 factorial upon n factorial upon n minus 3 factorial into 3 factorial. Correct. This is how you express NCR, right? I've done nothing, just expand the formula of NCR for 2nc3 upon nc3. Correct. From here, we can cancel out 3 factorial from the numerator and denominator. And upon rearranging the terms, what we are left with is, I'm going to rub this side and move on. So just remember that we had derived this, and from this part, I'm going to proceed to the next part, right? So after cancelling out 3 factorial from the numerator and denominator, what we are left with is 2n whole factorial, upon 2n minus 3 whole factorial into n minus 3 factorial upon n factorial. Correct. So I have done nothing, but I have just written the numerator and denominator, and I've taken the numerator, I've taken the denominator, inverted it, and multiplied it to the numerator, right? So the equation is in a more expressible form, right? I've done nothing but that. Moving on, let us expand 2n factorial and try to cancel out 2n minus 3 factorial. And similarly, let us expand n factorial and try to cancel out n minus 3 factorial. So 2n factorial could be written as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 whole factorial. Correct. So this can then be cancelled out from the numerator and denominator. And similarly, n minus 3 factorial can also be cancelled out, because n factorial could be written as n into n minus 1 into n minus 2 into n minus 3 factorial. Correct. So then I can cancel out n minus 3 factorial from the numerator, and I can cancel out 2n minus 3 factorial from the denominator. So that is just what I'm going to do. And the next form of this equation would not have n minus 3 factorial and 2n minus 3 factorial, because they are going to be cancelled out from the denominator and the numerator respectively, right? So that is what I'm going to do. So 2n factorial can be expressed as 2n minus 1 into 2n minus 2. I'm going to put the brackets here so we don't get confused. And then we are going to expand n factorial also. 1 plus 2. Correct. As we can see very clearly that this gets cancelled out from here. Then n minus 1 and 2n minus 2, this could be written as 2 into n minus 1. Correct. So we can cancel this out and write 2 in place of this. After we have done that, the simplified version of the equation on the LHS is now nothing but 4 into 2n minus 1 upon n minus 2. So this is the equation from the LHS. Correct. Now to solve for part number A and part number B, all I am going to do is equate this to 12 for the first part and 11 for the second part. Correct. So let us solve for the first part first. Let's equate this to 12. After doing that, I'm going to cross multiply the denominator. I'm going to take it to the other side and let's see what I'm left with. So 4 into 2 is nothing but 8n minus 4 is equal to 12n minus 24. Correct. Taking 8n that side and minus 24 that side, what I'm left with is 20 equal to 4n. Correct. And then n is nothing but 20 divided by 4, which is nothing but 5. So this is the solution for part number A, n equal to 5. Let us try and solve this for the part number 2 as well and equate this to 11. Correct. So the LHS is going to be same in this case as well. 4n 8n minus 4 equal to 11n minus 22. Again, taking 8 in that side, 22 this side, what I am left with is 18 here and 3n here. So n is nothing but 18 divided by 3 is nothing but 6. Correct. So the main crux or the main takeaway from this question is to find the similarity between part A and part B. If you take a look at part A and part B carefully, you'll be able to observe the LHS in both these cases is going to be the same. So rather than simplifying the equation in this form twice, just do it once and equate that to 11 and 12 in each of the cases. And that is how you're going to be able to find out the value of n efficiently, right? So that is something that you need to keep in mind. Rather than just jumping at the question, first try to understand the similarity between similar kinds of question and solve them in one go, right? That is how you're going to save time. So moving on to question number 3. So each and every other question on this exercise is fairly straightforward, a fairly straightforward application of the formula of NCR, and you're going to be able to see that we are going to skim through the next questions, right? Because they are not going to be very hard. So the next question asks of us, how many chords can be drawn through 21 points on a circle? Let us suppose that you want to draw a chord in any circle. Let us suppose that this is a circle and you want to draw a chord. A bare minimum condition to draw any chord in a circle is to select 2 points upon it and draw a straight line through them, right? So if suppose I select these 2 points and I want to draw a chord through them, what I'm going to do is I'm going to draw a straight line through these 2 points, and I've got myself a chord. So to draw a chord in this particular circle, I have a choice for 21 points. Correct. Off of these 21 points, all I require is 2 points for a chord to be unique. Correct. So the question basically boils down to 21C2 is going to give us the number of chords. Correct. And if you solve for 21C2, what you're left with is 21 factorial upon 19 factorial into 2 factorial, right? This can be simplified as 21 into 20 upon 2. Correct. I'm cancelling out 19 factorial and writing in place this, right? I can cancel this out as well, and the number of chords that I finally get is 210. So as you can see, it was a very straightforward application of NCR, and just by visualizing what you are required to do in a question, these questions are very easy for you all to do, right? You just have to understand what is asked of you and apply that into your solution, and there you'll have it, the solution itself, right? Moving on to question number 4. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? So the total number of boys that I have is 5, and the number of boys that I actually want to select is 3, right? And the total number of girls that I have is 4, and off of this 4, the number of girls that I want to select is also 3. So I can select 3 off of 5, which can be expressed as 5C3, and then that could be multiplied as me selecting 3 girls from 4 girls that are available, and that is nothing but 4C3. And there you have it, your solution itself. So these are very straightforward questions. You just need to select, just need to do what is asked of you in the question, and there you'll have your solution, right? So 5C3 is nothing but 5 into 4 into 3 upon 3 factorial, and 4C3 is nothing but 4 into 3 into 2 upon 3 factorial. 3 factorial is nothing but 6, and when you cancel this out, 5C3 is nothing but 10, and 4C3 is nothing but 4. So the number of unique committees that you'll be able to form is, a number of unique teams that you'll be able to form is equal to 40. Correct? Because 4C3 is 4 and 5C3 is 10, and when you multiply them, the answer that you get is 40. Correct? So this was also a very straightforward question. You just need to select 3 boys from 5 boys that are available to you, and you select 3 girls from the 4 girls that are available to you. And when you multiply them, because each of the combinations are going to be unique in themselves, so that is how you're going to arrive at the final answer. Correct. In question number 5, we have to find the number of ways of selecting 9 balls from 6 red balls, 5 white balls, and 5 blue balls if each selection consists of 3 balls of each color. So this is just an extrapolation of the previous question wherein we had to select 3 boys from 5 boys and 3 girls from 4 girls, right? In this case, we have to select 3 red balls from 6 red balls, 3 white balls from 5 white balls, and 3 blue balls from 5 blue balls. Correct? So that is nothing but selecting 3 from 6, selecting 3 from 5, and again selecting 3 from 5. Correct? So when you multiply each of them, what you finally get is 6C3 into 5C3 into 5C3. We just calculated the value of 5C3 and we had obtained that as 10. So that is what I'm going to do. I'm going to write 10 and not going to do anything else here. And let us obtain the value of 6C3 as well. So 6C3 is nothing but 6 into 5 into 4 upon 3 factorial. And 3 factorial is nothing but 6. So you can cancel that out from the numerator and denominator. 5 into 4 is nothing but 20. So I'm going to replace that by 20 here. So 20 into 10 into 10 is nothing but 2000. So there are 2000 unique ways of selecting 9 balls from 6 red balls, 5 white balls, and 5 blue balls, wherein each color ball has 3 number of representation in the final selection, right? So there are 2000 ways you can do that, right? So this was also a very straightforward question, and it was kind of an extrapolation of the previous question itself. So I don't think that is going to be difficult for you all to do. Moving on to question number 6. Question number 6 is also fairly straightforward, but there is some thinking involved. And so we'll take a couple of minutes to see what it actually tells us before moving on, right? We have to determine the number of ways a 5-card combination out of a deck of 52 cards if there is exactly 1 ace in each combination, right? So in a card deck of 52, there are 4 aces and 48 other cards. We have been told that we need to select a 5-card combination and one of them is compulsorily an ace, right? So out of 5 cards, 1 is ace plus 4 other normal cards. And how many aces do we have in a deck? 4. And normal other cards are 48. So our selection particularly boils down to us having 1 ace from 4, correct? Because we're going to select at least 1 ace, which is compulsorily going to be an, out of the 5-card combination, 1 is going to be compulsorily an ace. So we are going to select 1 ace from the 4 aces that are available to us, and the rest cards are going to be 40. We are going to select 4 other cards from the 48 other normal cards that have been given to us, right? So that is how you're going to arrive at a solution 4C1 is nothing but 4 upon 1, which is nothing but 4 itself. And 48C4 is nothing but 48 into 47 into 46 into 45 upon 4 factorial. Correct. When I'm going to solve this, the final answer that you're going to arrive it as is equal to 4 into 194,580. And when you are going to solve this, the final answer that you are going to arrive it at is 778,320. And that is your final answer. These are the number of 5 card combinations that are possible when one of them is compulsorily an ace and rest of them are other normal cards, right? The other caveat in this question that you need to observe is that we have been told that there is exactly one ace. If we had not been given that, and if we had been given a condition that we had at least one ace, then the question would have been completely different, right? But we have been already told that we have only and only one ace in the 5 card combination, and that is why the question is fairly straightforward for you to solve, right? So moving on to question number 7 of this exercise. Question number 7 tells us, in how many ways can we select a cricket team of 11 from 17 players in which only 5 players can bowl if a cricket team of 11 must include exactly 4 bowlers, right? So we have a cricket team which has 11 players, right? And we have a selection of 17 players that is available to us. In an ideal case, we would just select 11 players from 17 players, and that would be our answer. But there is one additional condition that has been imposed upon us. We have been told that of these 17 players, there are only 5 bowlers. And in a cricket team, we want to have exactly 4 bowlers available to us. So these 17 players are composed of 5 bowlers and 12 other players, right? We want to have 4 bowlers in our team, and rest 7 can be any other bowler, any other batsman or an all-rounder, right? So off of these 5 bowlers, we need to select 4 bowlers, and off of this remaining 12 players, we need to select 7 other players. So after doing and understanding the question well, the solution that we arrive it as 5C4, because we are going to select 4 bowlers from the 5 bowlers that are available to us, and we are going to select 7 other players from the remaining 12 players. So 12C7, correct? After we have simplified this, the solution that we arrive it as is, so 5C4 is nothing but, which can also be written as 5C1, and 5C1 is nothing but 5 upon 1, right? And just to erase this, and 12C7 is nothing but 12C5, and 12C5 could be written as 12 into 11 into 10 into 9 into 8 upon 5 factorial, right? What I've done is I've represented 12C7 as 12C5 because both of them are going to be the same, and I have written 5C4 as 5C1 because they are also going to be the same, right? So when you solve this further, what you're left with is 5 into 95040 upon 120, which could then be simplified as 5 into 792, which when you solve, you get 3960, right? And this is going to be your final answer, correct? So that is how you're going to solve this question. Just keep in mind that the choice of the bowlers and bats, other players that you want to have is specified. If it is specified to you in the question in itself, then proceed in that manner itself, right? So moving on to question number 8 for the day. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected, right? So off of 5 black balls, we need to select 2 black balls and of 6 red balls, we need to select 3 red balls. Correct. So when we do that, the final solution that we are left with is 5C2 into 6C3, and we have already calculated the value of 5C2, which is nothing but 5C3, which is nothing but 10, and the value of 6C3 has already been calculated by us, which is nothing but 20. So that is just 20. And when you solve this, the final answer that you arrive it as is 200. Correct. And that is going to be our answer for question number 8. So we can see that our speed of solving question has increased considerably, and that is because of our innate understanding of what is asked of us in the question. If you look at each of these 9 questions, they are of a fairly straightforward type, and most of the types are repeated across the questions, right? So if you find the pattern, you'll be able to arrive at the solution quite fast. Moving on. Let us see question number 9. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? Right. So we need to select 9 courses. We need to select 5 courses. We need to select 5 courses of the 9 courses that are available to us. But we need to subtract something because of these 9 courses, 2 are compulsory. So we don't have a selection in those courses. So that boils down our choices to select from is 7, and we need to subtract 2 from here also because 2 courses have already been allotted to a student because they are compulsory, right? So the number of choice that we have left with is 7, and the number of courses that we can actually choose is 3, right? So number of choices that are available to us is nothing but 7C3, could be expressed as 7 into 6 into 5 upon 3 factorial is nothing but 6. The final answer is 7 into 5, which is nothing but 35. So the number of choices that we have to select courses is 35, right? So as you can see, we have finished the exercise, and it was a very straightforward exercise to say so. And let us now apply everything that we have learned in the last 4 exercises that we have solved. In the last exercise, which is going to contain the mixtures of all the questions that we have solved, right? So we are going to jump to exercise 6.5. To rub this as well, because we are going to jump to exercise 6.5. This is the miscellaneous exercise of this chapter, and let us just scroll down. So as you can see, the types of question that we're going to attempt are going to be same as in the theory that you have already read. So in daughter, so let us, without wasting any more time, let us go on to the miscellaneous exercise of this chapter. It's not actually 6.5. I'll just rub this.